Hello and welcome to the Daily Space for today, February 28th, 2019. I am your host, Dr. Pamela Gay, and I am here to put science in your brains. Today we have a special lineup. In addition to doing the news for the first half hour, we are going to have scientist and science artist extraordinaire, Dr. Bill Hartman, joining us at 1:30. So stick around and please, if you can, share this information out with your social media and on your Discords because it's going to be an especially awesome second half hour. I have to admit, I actually was a total fan of Dr. Hartman's artwork when I was a middle school kid. So I'm really excited to get to be able to do this interview. And I'm even more proud to say that starting in 2019, when CosmoQuest moved to the Planetary Science Institute, I'm actually at the same institute as Dr. Bill Hartman. So this is an especially awesome episode for me and hopefully for you too. Now, in addition to that good news, I do want to say you may have noticed that Monday and Tuesday's opener started with a preview of my dogs, and I tried to replicate what my co-host Annie Wilson does with when bits are donated, treats go to dogs. But my dogs are not her dogs, and mine misbehaved. Until I can get them to behave, I'm not going to have them joining me on the Daily Space because I've had complaints about the audio quality of the show. And I know that there are a lot of people out there who, they're here for the audio. So we're going to take care of those people and listen to their feedback. Now, it's time for some news. We have a great lineup today, and I am going to start with news of, the European Space Agency is working on training its scientists to explore Mars by exploring the Atacama Desert. Currently, there is a group of scientists and engineers who have taken a mock-up of the ExoMars 2020 rover. This, as you may remember, has been named the Rosalind Franklin rover. And the mock-up has been taken to the Atacama Desert because that desert is perhaps the most Mars-like location here on our own planet Earth. And they want to test the abilities of this life-seeking rover, or in this case, a mock-up of the life-seeking rover, and also practice all of the skills the scientists are going to need to control their robot from, not just the thousands of miles away that it is when it's in the Atacama Desert, but the millions of miles away it will be when it's on Mars. The trials that they're doing are testing out new software they have named Charlie. I can't explain that name, but I find it highly endearing. And along with testing out new software, they're also testing out a new control center. The European Center for Space Applications and Telecommunications at Harwell had been used to host this new remote control center for the ExoMars rover. Now, when you have a bunch of people learning new software, working in a new location, you definitely need multiple rehearsals before you get to the red planet. And this is just a cool chance to see the kinds of images that we can expect to be getting from the Franklin rover when she gets to Mars. This particular image that you're seeing is just one such example. Here you see its version of PanCam, a panoramic camera, looking out towards the horizon at a series of boulders that litter not the Martian landscape, but the Atacama Chilean landscape. So this is pretty cool, getting to see these dress rehearsals take place. And it also gives us a chance to figure out what are the things we need to figure out. Quite often, it's not until you start playing with your rover, your robot, your software that you realize, wouldn't it be cool if? And at this point, there is time to react to those ifs and make the changes, the upgrades, the user experience changes that are needed to make sure this rover is as capable of doing science as is absolutely possible. Now, moving out a little bit further from home, in fact, moving, about 25,000 light years from home, we have new news coming to us from the inner bits of our Milky Way galaxy. Our galaxy has within its center a massive, supermassive black hole. This black hole is, if you want to go looking for it, located in the Sagittarius constellation, which is currently not ideal viewing, but will be starting to crop up as the spring progresses. When you look into the Sagittarius teapot constellation, you're actually looking towards the heart of our galaxy. And if you use the right kind of telescope, you can peer through the gas and dust that lies between us and that heart of the galaxy and see the innermost stars orbiting, see the innermost clouds of gas moving around that center of our galaxy. Well, recently, astronomers using the National Astronomical Observatory of Japan noticed that a cloud with the ever so poetic name HCN 0.009-0.044, that is its galactic coordinates, they noticed that this particular cloud of gas was moving extraordinarily, not like you'd expect. And as they examined how they could explain the motions they were seeing in this cloud of gas, what they realized is this is probably a cloud of gas that is host to an intermediate mass black hole. Now, intermediate mass black holes are one of those things that we know should exist, that we see through gravitational wave experiments when black holes merge, but finding intermediate mass black holes in the wild has just not been a thing we've been so far really capable of doing. And finding this one located so close to the center of our Milky Way, it's worthwhile in a number of different ways. So first of all, this particular intermediate mass black hole is about 30,000 times the mass of the sun. And it was found by looking at how the gas was moving, measuring those motions, noticing that those motions, described how much mass had to be confined in a volume about that of our own Milky Way galaxy, and not Milky Way, our own solar system rather. And the only way to explain 30,000 times the mass of the sun being located in a volume the size of our solar system was with an intermediate mass black hole. Now, because this gas and this black hole is located snuggled in close to the Milky Way's supermassive black hole, it tells us that that black hole over time is probably going to spiral closer and closer in and merge into the Milky Way supermassive black hole. This is additionally important because this helps us understand that, yes, supermassive black holes in the centers of galaxies are growing by consuming smaller black holes, are growing through merger processes. So this really is building blocks coming together and growing larger and larger supermassive black holes over time. So this particular discovery made simply by going, that gas is weird, and taking the time to mathematically model it and figure out what is going on. This particular discovery led us to an intermediate mass black hole in the wilds and evidence that, yes, black holes are growing through the process of mergers of larger and larger black holes. So this particular black hole is located about 20 light years away from the supermassive black hole Sag A star, some of you may know it as, and it's not going to be merging anytime soon. When it does, there will be a massive release of gamma rays, X-rays. It will be quite exciting and quite bright, and we won't be here to see it. But it's amazing that software models allow us to understand what will be happening. After all, science is taking what we see, taking what we understand through math and putting it together to, well, model the past and look into the future. Now, in terms of using math to predict what may someday be seen, our final science story of the day is, well, a story of the planet we have not found yet. This is the predicted Planet 9. Several years ago, you may remember that Michael Brown and Konstantin Bergagin predicted that based on the orbits they were seeing of a variety of trans-Neptunian objects located out in the Kuiper Belt, there should be a massive planet that is causing these orbits to get, well, bent out of shape all in one particular direction. And if you look at this particular graphic, you'll notice that there is in the center a little tiny red circle. That red circle represents Neptune's orbit. There's also a large yellow circle that is slightly off center. That's slightly off center, not as circular as your eye may be perceiving it, ellipse, is the predicted orbit of Planet 9. Now, in addition to Neptune's orbit and Planet 9's orbit, there are a variety of ellipses in green and purple. The green ellipses indicate detected known Kuiper Belt objects that have orbits that are predicted to be strongly influenced by both Neptune and Planet 9. The purple ellipses are the orbits of known objects that appear to be warped primarily by just Planet 9. By putting together all of these actual known orbital paths through the sky of these known Kuiper Belt objects, by mathematically working out what it would take to get everything skewed in one direction in our solar system rather than randomly oriented as we would have otherwise expected. Well, in order to get what we see, it appears more and more that you need to have a single massive object. And the single massive object that they're predicting is theorized to be about 5 Earth masses. And its orbit unfortunately means that while 5 Earth masses compared to our Earth is quite large, compared to, well, how far away it is, even at that size, it's going to be incredibly faint. And we don't know where, from what we're seeing, in its orbit it would currently be located. This means that right now, to try and find this Planet 9, astronomers are looking at the entire path around the sun of this object. So far, we haven't found it. Now, the computer data reduction pipeline that is being used by the various teams of scientists working at Caltech and the University of Michigan and other institutions to try and find this object have gone through and re-examined survey images taken by a myriad of different telescopes. And in their data pipeline, they have been able to recover all of the known Kuiper Belt objects. They've been able to find previously unknown Kuiper Belt objects. They know their software works. What they don't know is, well, is Planet 9 so dark, so non-reflective that it just wouldn't show up in the current surveys? Is it in one of those regions along this orbit that hasn't yet been examined by any of the survey telescopes? We don't know. Now, when it was first predicted that Planet 9 was out there about 3 years ago, we had hoped that maybe we'd be able to uncover it in just a couple of years. And it's now been 3 years. And now, as reality sinks in, it is now hoped that in the next 10 years, with the Large Synoptic Survey Telescope coming online, with the, we hope, upcoming launch in a few years, maybe, of the James Webb Space Telescope, maybe between these two instruments, we will be able to find this object. But for now, it's a matter of keep looking, keep hoping. And finding this object is even harder than just trying to find something faint on the sky. Beyond just being faint, because of its great distance, the bar that you see up in this image, that bar up there, I can't quite point to it. That bar up there, that's 200 astronomical units across. That's 200 times the distance of the Earth to the Sun. This is a massive orbit. And at so great a distance, Planet Nine's motion through the sky isn't so much dominated by its own orbital motion as it is by the parallax of the Earth moving, and because it's so nearby, it will appear to jump side to side relative to the background stars. And when you're looking for something based on parallax, it gets even harder. And here we can even hope that maybe Gaia will find it, although Gaia's probably not looking faint enough to find it. So all the frustration is ours, but hopefully, well, I don't know if you know the full saying, but curiosity may have killed the cat, but satisfaction brought him back. And hopefully satisfaction will also be ours in the coming years. So here is all my best wishes being sent to all the various observers around the world looking to find Planet Nine in outer space. So that concludes today's news. I am now going to take your questions for about 10 minutes. We are then going to take a short break. And after that break, we are bringing on scientist and painter Dr. Bill Hartman, a colleague, I am proud to say, over at the Planetary Science Institute, the same institute where I am now employed. He is going to be talking to us about the science he has done and how his painting, well, gives us a new perspective on what we're learning about the possibilities of other worlds and what our views may be should we be able to, well, set foot, set wheel, set rover on their surfaces. Okay, so as a friendly reminder, when you type in your questions, please at CosmoQuest X so that I can spot them a little bit easier. And while you are typing in those questions, I am going to do our standard station identification. The Daily Space is part of CosmoQuest. We are your place to learn and do science. In addition to bringing you the Daily Space most Mondays through Fridays at 1 p.m. Eastern, 10 a.m. Pacific, that's 6 p.m. London time, we also bring you the Sunday Science Hour with Annie Wilson and launches, landings, and other spacey special events as they occur. Give us a follow to find out when we go live, because you never know exactly when some breaking space news is going to happen. We are here thanks to the generous contributions of people like you. We are sustained through your subscriptions. Every bit really matters. Thank you so much for all that you have given. You have allowed me for one more month to make payroll. If you want to have additional benefits to go along with your donations, check out our Patreon at patreon.com/CosmoQuestX and find out how you can be a supporting member of our community. So thank you all so much. And now I'm going to look for your questions in the chat. Scrolling up. And once again, we are a collaboration of the Planetary Science Institute working with Youngstown State University. So Larry Weird and Proud is asking, will Curiosity reach the summit of Mount Sharp? Well, it's kind of hoped, but as to when, I don't dare guess. It's sort of like you don't wish a theater person good luck. You also don't count your science before your spacecraft gets there. Like every computer, Mars Curiosity periodically undergoes reboots, resets, work stoppages, issues, and I'd rather just say keep on roving, keep doing science, and tell you yes, hopefully it will get there, but I'm not going to make any promises as to when. Hanny is stating, would the disruption of having this massive black hole in the vicinity lead to star creation near Sag A star? Well, there's lots of different reasons for there to be star formation near Sag A star. This is an extremely dense region in our galaxy. There are lots of different things going on that can shock and collapse clouds of gas and dust that are otherwise happily supported by their own internal heat. So star formation in the centers of galaxies, that's just a thing. And we don't have substantial star formation going on right now. But this is mostly because we don't have substantial gas and dust in there right now. Now, someday in the future, in fact, about 5 billion years from now, our galaxy and the Andromeda Galaxy are going to interact. They are going to merge and collide. And this process is likely going to lead significant amounts of gas and dust to, well, stream into the center of our Milky Way, triggering massive amounts of star formation. Our central supermassive black hole is going to come alive, eating that material. Quite likely, we will have some sort of jet activity. But again, we won't be around. So I can tell you what should happen. And what's awesome is we can look out towards other systems, in particular, the mice galaxies, the antenna galaxies, and we can see this process as it happens. The sky is big. There's lots going on. And if we look far enough and hard enough, we can almost always find an example of the kinds of phenomena that are real and predicted to happen here that have already happened somewhere out there. Hanny's Rover is asking, could we detect supermassive black holes in other galaxies? They are detectable from gravitational wave observations. I don't believe we currently have the sensitivity to do that, though. That will take, I believe, a different kind of configuration of a LIGO-like gravitational wave detector. This is a new technology for us. We're still learning how to detect things from their gravitational waves. So Veronica Cure asks, could the density of Planet 9 make it smaller than predicted? Yes. So at this point, we can tell you roughly what the predicted total mass of Planet 9 will be. What we can't tell you is this going to be an ice giant? Is this going to be a small block of lead? We don't know. And while planetary models can tell us what is likely, the universe keeps liking to surprise us. It turns out the creativity of the real universe vastly outdistances the creativity of our planet-forming models. We keep finding planets doing things, being things, behaving in ways that, well, no one imagined when I was first learning planetary science. So, yeah, we're just going to have to see Planet 9 before we know exactly what it looks like. So approximately 5 Earth mass. I'm going to hold it at that, and everything else, we just need to wait and see. So Fenring asks, can we focus at finding more orbits of smaller bodies to better infer the orbit and location of Planet 9? Finding more bodies, from what I understand, will help us better understand where the orbit is, but I don't honestly know if we can get better information on where in its orbit Planet 9 would be. I just don't know. So Archie Haddock asks, I've heard we have found a Earth-like planet that is 5 times as big as Earth. How is the gravity there? How difficult will it be for our rockets to escape the planet's gravity there? Could there be advanced green guys out there that could not escape their planet's gravity? Well, so we have found a variety of worlds with a variety of different masses and radiuses. There's over 1,000 suspected and known, I think it's actually multiple thousand at this point, planets orbiting other stars. And they come in all different ratios of radius to mass. One of the things that I find particularly weird and pleasing is if you were able to somehow stand on a floating platform at the surface of the clouds of Saturn, you are located such a large distance from the center of Saturn that your mass would feel like it weighs what you weigh here on Earth. This is because we have a high density planet with a fairly low radius, so we feel significant weight. If we go to Saturn, which would float in your bathtub if your bathtub was big enough, your weight at that great a distance from the center means that you can have the same weight there. Now, when we find these 5 Earth mass worlds, it's their density that dictates. It's that ratio between how massive it is and how wide it is, what its radius is. It's that ratio that dictates how much you feel like you weigh. If you crammed 5 Earth masses of material within the radius of the Earth, you'd need completely different biology. You'd need life forms that have a much stronger skeletal structure, perhaps even an exoskeleton structure. Now, we're still figuring out these mass to volume, these density ratios. So yes, it's possible that there are worlds out there that, when they have the level of technology that we have, they're not able to build rockets to escape their world. Now, at the end of the day, it's just a matter of figuring out how to throw enough thrust onto a rocket to get off a planet like that. And enough explosives will do it. But that takes time and advanced technology. But escape is, unless you get to being the mass of a black hole, in which case life isn't going to exist. Escape is always possible. So Q23 asks, what if Planet 9 is made of dark matter, so we will never be able to see it? Now, the thing with dark matter is, as near as we can tell, it doesn't like to work and play well with others, including itself. This means that individual dark matter particles don't bond together to form structures the way the atoms in my mug bond together. So if you have a Planet 9 worth of dark matter, that dark matter is going to be like, yeah, I don't care. I'm just going to come over here. I'm not going to bond. I'm not going to form a structure. In fact, you can't confine me into the volume of a planet. So what it can be is matter that is dark. It can be made of materials that just don't reflect sunlight a lot and very hard to see. But it can't be made of dark matter in terms of that stuff that doesn't interact with the electromagnetic force, that doesn't reflect light, that is that invisible component of our universe. So it's the subtle difference between matter that is dark and dark matter. And astronomers really shouldn't be allowed to name things because we do it poorly. Okay, so DPI 2009 is giving us an update. Crew Dragon and Falcon 9 rolled out to the launch pad ahead of the spacecraft's first test flight. Liftoff targeted for 2:49 a.m. Eastern on March 2nd. And we will be bringing that to you live right here on CosmoQuest. Tune in roughly an hour ahead of time. Annie and I are still figuring out which of us are going to be here through the night to bring you that live coverage. So thank you, Beowulf Schaefer, for joining us. Hello and welcome. So that is bringing me to the end of today's questions. Those answers took longer than expected. 2 quick notices, both directly related. If you would like to join me, Fraser Kane, Skylius, John Matt Gaultier, Paul Matt Sutter, and others at Joshua Tree National Park in June, you can do it. Go to astrotours.co and sign up now. I will be hugging a Joshua tree. We may be experiencing the last generation of Joshua trees this park will ever have. So join us. And if June doesn't do it for you, join me in late August for a tour through the American Southwest, starting in Tucson, Arizona, and traveling up to Las Vegas, baby. We're going to be touring through my favorite part of the world with amazing landscapes, dark skies, and your chance to, well, share stories of the sky with me. So go to astrotours.co/starstrider to sign up for that one. And while you think about whether or not this is something you want to do, I'm gonna, well, switch screens. And we are going to be joined in just a moment by Dr. Bill Hartman. So stay tuned and don't go anywhere. We will be right back.